Okay, to get us started out here, I'm going to see if you can remember the calculations from the first hour. I'll have you do those three, find the missing numbers. So if we take a look at the first one up here, 35%, of course, is going to be 35 over 100. 80 go on top or bottom? On bottom. Perfect. We'll cross multiply and divide. 35 times 80 divided by 100 is 28. So 28 is 35% of 80. For the next one, 27 is blank percent of 60. So we're missing the percent, so it's blank out of 100. So the 27 and the 60, which one goes on top? $27 on top, 60 on bottom. Perfect. Once again, we'll cross multiply and divide. 100 times 27 divided by 60 is 45. 27 is 45% of 60. And then we have 54 is 90% of blank, so we have 90%, 90 out of 100. 54, top or bottom? So go on top, 54 is 90%. And we cross multiply. 100 times 54 divided by 90 is 60. How many of you had all three of those right? Perfect. So we're ready to move on. So we're going to get into more of our word problems now, because that's kind of what life is. And we're talking about business applications. We're going to deal with word problems. So let's say that Steve has a wage of $12.40. He was just informed he is about to receive an 80-cent pay increase. What percent is this increase? So it's a percent problem, so we're going to have the percent over 100. In this case, do we know the percent? What percent is this? We're looking for the percent. So it is blank over 100. But we can still label this. The percent is going to represent his wage or the increase. It's going to represent the increase. The 100% is the starting amount. That would be his original wage. So on the other side over here, his wage of $12.40 is going to be on bottom. That's the whole amount, or the starting amount at least. And on top will be the 80 cents. And we will cross multiply and divide. 100 times 80 and divided by the $12.40. Now I probably should have said here to the nearest, I don't know, 1/10 of a percent or something like that. Let's go to the nearest 10th of a percent. So we'll go 100 times 0.80 divided by 12.4. Gives us 6.45, which will round to, what is it, to the nearest 10th? 6.5%. Perfect. Let's look at XYZ Corporation. Had an increase of 846 units in sales. this was a 3% increase over projected sales. What were the projected sales? So here we actually have the 3%. So 3 out of 100. Does the 3 represent, we have projected sales here and we have an increase. Which one is represented by the 3%? The increase. So the projected has to be the 100. Yep. So on the other side, we have the 846 units. Does that represent the projected sales or the increase? Increase of 846 units. So now we find the projected sales, which is going to be 100 times 846 divided by 3, which will be, what, 28,200? Does that look right? So our projected sales was 28,200 units. So you can see, even with the basic percent problems, just writing them out and matching pieces up can help us set up that proportion and find our correct answer. Next, we want to move up to a type of problem that involves a little bit more detail than that. Most percent problems are not just simple straight percents like that. They involve some sort of a change. It can be either an increase or a decrease. If we're dealing with an increase, we have a full amount, 100%, plus some sort of an increase, which gives us a larger total, a total that is more than 100% of what we started with. If it's a decrease, we start out with 100% and we are subtracting that decrease, which leaves us with something that is smaller than what we started with, or less than 100%. And in fact, it's this idea right here that we use to set up our formulas for each of these. For example, let's say that Pete had 120 units last quarter. This quarter, Pete is up to 156 units. What is the percent increase? Well, if we look at this, we have the 120 and the 156. We try to just set it up as a simple percent proportion. It's not going to work really well. But if we look at this, first of all, it's an increase, which means we're going to start with some sort of beginning amount, old or whatever, we'll call it the beginning amount. And we're going to add some sort of an increase to it. You get some sort of a new amount or ending amount. And in any sort of percent problem, as we saw up here with these other ones, on one side we have the percents, but each item is described not only by the percents, but also by another number, either dollar amount or just a pure amount or whatever. So the same thing is going to go down here. Each of these numbers, the beginning amount, the increase, and the ending amount, are going to be represented by the percents, but also by some other number. In this case, it's the number of units. So let's look on the percent side. It looks like on the percent side we don't know anything because there's no percents given. We're asked to find the percent increase. So this right here is the number we're looking for, is the percent that represents the increase. But we do know one number on the percent side. When it comes to percents, we always know 100%. The whole amount or the beginning value. And here we have the beginning value, or the old value. That is 100%. So I'm going to fill in 100 there. On the other side, we have our number of units. We have 120 and 156. Which one of those is the beginning amount? The 120. That was last quarter, the old amount. What is our new amount, or the ending amount? 156. Now, just to point out, these words in here, beginning and end, we could have old and new or whatever. Last quarter, this quarter, those words don't matter as long as we have the numbers matched up. As long as you know what they mean. They don't have to be the same as mine. Now, looking at this, that's all the information we're given, but there is some information we can figure out rather quickly. Mainly this right here, the amount of the increase. How do we find that? Well, it's just the difference between 120 and 156, which is 36. 156 minus 120 is 36. If we look at this here, beginning plus increase equals the ending amount. That has to be true on both sides. 120 plus 36 equals 156. Same over here, 100% plus the percent increase has to equal the percent of the ending amount. So now we have numbers that we can work with. We have one row in this chart where we have both the percent and the other number. That's the beginning amount here. And then for the row that we're looking for, has our missing value, we have the other number. So we can now set up our proportion and solve. In fact, we can actually do it right within the table. We don't even have to pull things out. This bottom row here, we don't have the second number, so I'm just going to cross that off. We're not going to use that in this problem. So now we can cross multiply and divide. Just like in a proportion, we'll cross multiply the two numbers at the diagonal. So 100 times 36 is 3,600. Then divide by the other number. Dividing by 120 gives us 30. So this number here is 30. It is a 30% increase over last quarter's amount. Now let's look at a different one. Last year's price was $2.80. This year the price increased 15%. What is the new price? The same type of thing. We're looking at an old price. Again, you can call this whatever you want. Old price, last year's price, whatever. Is it an increase or a decrease? It's an increase. So plus an increase equals a new price, or this year's price, or whatever words you want to put in there. And once again, each of those numbers, each of those items is going to be described by a percent and some other number. This time the other number is a dollar amount. So we look at our problem. We have 15%. The 15% is the increase, increased by 15%. And of course, what else do we always have with the percent? The 100, which is always the starting value or the whole amount, the initial value. In this case, the old price. So we have the 100 and the 15 over there. On the other side, what do we have? Well, we have $2.80. Which one of those amounts is that? Last year's price. That is the old price. So $2.80. What are we looking for here? We're looking for the new price. We need this one down here. In order to find that, we need the number on the other side. We're going to need this number over here. We can get that rather quickly though, because as we said, the old price plus the increase has to be the new price. We have on the percent side 100 plus 15 is 115. So in this one, this is the row. The bottom row here contains the number we're looking for. We also need a row that has both numbers. Which row has both numbers? The old price, right there. Has the percent and the dollar. So in this case, it's the middle row that we're not going to use. That has a number missing in it, so it's not going to help us. So we'll go ahead and cross multiply and divide. 115 times $2.80 divided by 100 is $3.22 is the new price. Any questions? Now on both of the ones we just did, we could have got around it without having to do it that way. We could have just subtracted 156 minus 120 to get the 36 and find that percent. Here, we could have found 15% of the 280 and then added it on. The 15% would have been 42 cents. We could have added it on. But there are problems where we cannot work with the percent increase directly. We could run into this problem. After an 8% increase, the new price is $450. Find the old price. Here, this 8% and the $450 really have very little to do with each other. So we can't find 8% of the $450 and subtract it out or anything like that. So let's look at this. We have an old price in this case. It's an increase, so plus an increase gives us a new price. Again, each one of those items is described by a percent and some other number. In this case, once again, it's a dollar amount. Being a business math class, most of the time, it's going to be a dollar amount. So let's look at the information we have. 8% is the percent of our increase. 450 is, careful, new price is 450. That looks like all the information we're given, but once again, we always have the 100%. That is the starting amount, the old price. And there's a number that we can calculate rather quickly here. Can anybody tell me what it is? 108. The 108, very good. 100% plus 8% means our new price is 108%. So we know we're going to use this row because we have both numbers. What are we looking for in this problem? The old price. We are looking for the old price, which is this one right here. We're not going to use the middle row again this time. So we're going to cross multiply and divide. 100 times 450 is 45,000. Divided by 108 is what? $416.67, I believe. So a little no, it's only 8%. Now, what if you had looked at this and said, hey, 8%, I'm just going to take 8% of the 450 and subtract it out. 8% of 4, and you don't have to write this down because I'm just showing you how that would have been wrong. 8% of 450 would have been $36. If I had subtracted that out, that gives me $414. That's $2.67 off. Why does that not work? Well, as I mentioned at the beginning, the 8% does not have a whole lot to do with the 450. The 8% is not based on the 450, it is based on the old price, which is the $416.67. If I found 8% of $416.67, if I cross multiply and divide there, I'm going to get $33.33. That is the amount that would take us up to 450. So in the percent problems, you have to be very careful to make sure you know what the percent represents and what it is based off of. That is why I'm stressing finding what this 100% represents in each problem. It represents the old price, not the new price. And whatever that 100% represents is what this percent is based off of. So since 100% is the old price, the 8% is based off the old price. So we cannot use the 8% with the new price. Let's say that you receive, as a good customer, a 14% discount. How much do you pay for items regularly priced at $250? So in this case, a discount, is that going to be an increase or a decrease? It's going to be a decrease. It's going to make the number smaller. So we have the regular price here. And we're going to subtract, because it's a decrease, the discount. And that's going to give us now what we pay. Or what you pay, or whatever, however you want to word it. Once again, each of those items is described by a percent and another number. And once again, in this case, it is a dollar amount. What do we know? Well, we always know the 100% is that starting amount, or in this case, the regular price. So I'll just fill it in. What else do we know?
Well, you know the discount is
14% goes in for the discount. And then we have the 250, which is regular price. What else can we find rather quickly from this information? The 114 over here is 100% plus 14% gives me 114% is what? No, actually, I screwed that up. That's wrong, Cody. We're not adding here. We are subtracting. So what's that get to be? You almost had me there, bud. 86. Sorry about that. 100 minus 14 is 86. And we are looking for the amount that we have to pay. So again, we're not going to use this middle row because we're missing a number. I'll show you in the next example. So we're going to cross multiply and divide. 86 times 250 divided by 100 is going to be 215. Does that work? So $215 is what we end up paying. Any questions so far? Okay. Let's see, your sales drop from 480 units last quarter to 408 units this quarter. What percent decrease is this? So again, this is a decrease. So we have last quarter minus this decrease or this drop, however you want to word it, is going to give us this quarter. And again, each of these items is represented by two numbers. We have the percents, and in this case, the other number is the number of units. What do we know? Well, we have 480 and 408, both number of units. Where does the 480 go? Last quarter, decrease, or this quarter? $480 is last quarter. 408 is this quarter. On the other side, on the percent side, do we have any information?
Well, we know 100.
We always have the 100 as the starting amount. So we'll put that in. What are we looking for here? The percent decrease right here. Now on the other side, to find that, we need to know this number, which we're going to find by subtracting. 480 minus 408 is 72. Now in this case, it's the bottom row we don't need. So we're going to go ahead and cross multiply and divide. 100 times 72 divided by 480 is 15. It's a 15% decrease. After a 6% surcharge, you pay $371. I'm going to abbreviate here. How much was it before the surcharge? I wonder if you guys tried to find that in your receipts and your notes. Okay, so we have, and however you want to word it here, I'm going to put down before the surcharge plus whatever that surcharge is gives us the price after. And of course, they're going to be described by percents and dollars. What do we know here? After the surcharge is $371. Good. What else do we know? Well, we have the 6% is the amount of the surcharge. And of course, the before, the starting amount is our base amount, is 100. And as you said, we can find the percent after the surcharge by just adding. Since this is an increase, it's plus. 100 plus 6 is 106. On the other side over here, we want to know the price before, which is right here. So we're going to ignore this middle row, and we're going to cross multiply and divide. 100 times 371 divided by 106 is, what'd you get? $350. Perfect. Should be 350. If you got 339, you probably tried to find 6% of this and subtract it. Okay, that's possible. Yeah, try to recalculate it and see if you can get it to work. Let me know if you don't. Okay, that'll cause some problems. Okay, let's look at. Let's say you receive a discount of 12% and save $39 on a purchase. What was the amount paid after the discount? I'm going to try that one in your notes too. So let's take a look. Again, the words don't matter. It's the general idea here. But let's say you have the full price or before discount. This could be increase or decrease. Decrease. So we're going to minus the discount. And we'll have the price after the discount. And again, we have numbers on both sides. There's percents on one side, and we're back to dollars on the other side. What do we know? What do we know? The storage room for the conference center is right above us, so a lot of times they're moving tables and chairs, setting up for tomorrow. So that's all that is. Hopefully, it's not as bad as it sounds. So what do we know here? Well, we know the 12%. Where does that go? The discount, percent discount. And of course, we know the 100% is always the beginning amount, the before the discount. We also have the 39, which is we save $39. That is the dollar amount of the discount. We want to know what is the amount paid after the discount. We want to know this number right here. We need to know this one to get it. What's this going to be? 88. Good. It's minus the discount. So 100 minus 12 is 88. So we don't need the top row this time. 88 times 39 divided by 12 is... What's that? 286. Is that what everybody got? That works. $286. Perfect. Okay, looking at this, that's basically as far as we can go with the percents, at least as for right now. We're going to take it further with other stuff. We've covered all of our order of operations. One last topic to cover before we review for the test is just some things on exponents and powers. We've talked a little bit about this and what that means. What does that mean? 8 to the power of 3 or 8 cubed or 8 to the third power. And how would you calculate it? Okay, 8 times 8 times 8, which is 512. Does everyone know how to do that on their calculator? Everybody's found that power key? Yes? Okay. Just to make sure you have it down, let's do 5 to the power of 6. Make sure it's 15,625. Anybody have any problems making it work? Okay, perfect. With that, the reason the powers are so important to us is those exponents are actually the basis of our number system. Look at 10 to the power of 3. What do you get? 1,000. 10 to the power of 5. 100,000. 10 to the negative 2. Well, that one doesn't make sense. You can't. How do you take 10 and multiply by itself negative 2 times? Well, this is where we go. We've had this come up a couple of times with numbers where the definition doesn't work. If you're dealing with negatives, multiplying 2 negatives, the definition of multiplication doesn't work. So what we do is we define that result to be whatever continues a pattern. So if we look at this, 10 to the 5th power is 100,000. What is 10 to the 4th power? 10,000. 10 to the 3rd power? 1,000. 10 to the 2nd power? 100. 10 to the 1st power? 10. So now if we look at this, we look for a pattern. When we're using a base of our exponent, a base of our power of 10, every time the power goes down by 1, what happens to the result? It's divided by 10. You drop a 0, yes, but mathematically we're dividing by 10. Here the power goes down by 1, we divide by 10. So let's continue this. 10 to the power of 0 would then have to be, the power went down by 1. If we divide it, what's 10 divided by 10? 1. 10 to the power of 0 is 1. In fact, anything to the power of 0 is 1. I don't do it to you guys, but in some of my tech math classes, I'll take some really ugly things like that and ask, what's that equal? It's to the power of 0, so it equals 1. You guys haven't made me that mad yet, so you're safe for now. So now with that pattern in place, what's 10 to the power of negative 1 have to be? Well, we would divide by 10 again. What's 1 divided by 10? 1/10. Oops, go ahead. 0.1 or 1/10. Okay. 10 to the power of negative 2, well, we divide by 10 again, would be 1/100th, and so on. If we look at the place values in our number system, we number this as 0, 1, 2, 3, 4, 5, 6, and so on. -1, -2, -3, and continuing that way. We have a decimal number system, or a base 10. What that means is our place values are exponents with a base of 10. As we've seen, 10 to the power of 0 is 1, 10 to the power of 1 is 10, 10 to the power of 2 is 100, and so on, giving us our place values. 10 to the negative 1 is 1/10, negative 2 is 1/100th, negative 3 is 1/1000, and so on. Our number system, our place values, are based off of these powers of 10. This is important for a couple of reasons. One, those of you who are computer science majors, when you do networking, you talk about binary numbers and hexadecimal numbers and sometimes even octal numbers. That's a number system that has different number bases, but those place values are going off the same thing. It's still 0, 1, 2, 3, 4, 5, and so on. Only now the base of that place value isn't 10 anymore. If it's binary, it's 2. If it's octal, it's 8. And for this class, we're not going to get into alternate number bases, but 8 to the 0 is 1, 8 to the 1 is the 8, 8 squared is the 64 place, 8 to the third is the 512 place, and so on. Also, for many of you, depending on what fields you go into, if you're going to the medical fields or anything like that, you start dealing with things that look like this. What does that mean? Well, again, we're going back to these place values. This is 340 million. But to shorten it up, they're taking that first digit, the 3, naming its place value 10 to the 8th, and writing it in what we would call scientific notation. So what you've learned is scientific notation. Most of you probably learned you put numbers in scientific notation just by moving the decimal point and counting how far you moved it, and that's your power of 10. That power of 10 actually is the place value itself of that first digit. Enough of that for now. It's probably about time to take our second break. Let's do that. It's about 7:15 now. We'll come back at 7:25 and start lecture again. The whole third hour is going to be review for our test next week. So when we come back, we'll get that done.